Welcome back to this key for homework 3.3. Alright, let's see what we got here. We know we have a W corner, and it's going to have to match up with the Q corner. And W goes to B. Q goes to R. Okay. BP. Uh-oh, don't know what that is. RS. Oh, B, P. Okay, the P must be the last corner. And R goes to S. That means these last two connect. Correct. And since WP is congruent to QR, and since, and since BP is congruent to RS, BP, RS. Since dubs P is congruent to QS, and we have side, side, side. The triangle WPBP is congruent to the triangle QRS. Uh-oh, we got some angles here. CY. But Y is the same as P. Okay, matches up. P, Y, P, Y, P, and there's some EB. This looks like angle side. This continues on the next page. So I will continue with the other packet. So segment CY, YP, YP, EB. Alright. I'm going to start with C and R. And that goes to Y and P. And then angle Y and angle P are congruent, so I can mark those. And this is E and B. The last two angles have to be congruent as well, but differently congruent, probably. So two arc marks. Ah, that's getting ugly. Alright. Congruence pattern. Angle, side, because the side we know is not in between them, but it works. And congruent statement, triangle. Triangle. You might be wondering why I say triangle like that. It's because I forget to write the symbol unless I say it obnoxiously. What's this? Side, angle, side? Let's hope that angle's in the right spot. BC, JK, BA, yeah, that's tricky, and JM, and B angle, it matches J angle, J angle, that sounds like jangle. And then by side, I forgot to mark the sides. BC, JK, BA, JM. Okay, by side, angle, side, we know this last side has to match CPCTC. Also, just logically, there's no other triangle that makes if these are cut off here because these are certain lengths, and that angle's locked. Congruence pattern. Congruence statement. Triangle. Oh, ABC. Nice. Triangle. MJK. Michael Jackson? Kidding. Oh, and then the big one. Right. Let's switch back to the other book. GE bisects BC and AB because I was given that information. GE bisects both BC and AB. AB bisect. And BC bisect by E. By specifically GE but that means the tip of this is cutting it in the middle. All right, so that's all we know so far. Also, this is a rectangle. So BED has to match AD, and they also say BG is congruent to DE. BG DE by the transitive property. And we haven't really talked about the transitive property very much, but it says that if A equals B, I gotta give this, hopefully you've heard of this before. And if you didn't, you looked it up, right? You Googled it. What is the transitive property? It's famous. It's a famous property. If A equals B and B equals C, then A equals C. By the transitive property. If one thing equals something, but that something equals a third thing, then the first and the third thing are congruent. You'll hear people make jokes about this, like if the Seahawks beat the Eagles, but the Eagles beat the 49ers, then the Seahawks are better than the 49ers by the transitive property of football, which is not a real property, but it's a joke based on the transitive property of mathematics, which is a real property. So let's look at our diagram. What are we trying to prove? Olivia realizes that she already has two sets of corresponding sides that are congruent, triangle BGE and EDC. Now she only needs to prove the third side is congruent to have SSS, or maybe fine. I don't get it. Oh, here we go. The assignment is to prove, I broke my pencil. Triangle BGE is congruent to EDC. BGE, EDC. And a two-column proof. Okay. Third side's congruent. What is she talking about? Oh, yeah, she wants to prove that DC equals GE. Or maybe find some angles that are congruent in order to have a different congruence pattern. She wonders if the rectangle can tell her more about the two triangles. So she knows some more things. Because it's a rectangle, all those angles are right angles. I think that's all we need, right? And a linear pair. Yeah, and a linear pair to make the right angles. Okay. I'm going to do something crazy. And fun. Maybe zoom out a little bit. Hope my broken. I have another pencil. All right. So she already said that quadrilateral ADEG is a rectangle. That's given. And she already said that this thing bisects those things because that's given. So let's go with the next factoid, which is that BE equals EC because of definition of bisect. BE is congruent to EC. Why? Def of bisect. Definition of bisect. Also, it also bisects AB, so BGGA, BG congruent to GA. Def of bisect. Now we're on a roll. GA is congruent to ED, both opposite sides of a rectangle. GA is congruent to ED. Op sides rect. Get rect, rectangle. Sorry, I'm just kidding. I don't know. Is that rude? I don't even know what that means. Sorry, I shouldn't have used slang that I don't really know what it means. Fixing some things. I do know what it means. I just don't know if it's really mean or if it's just playfully mean. Now we're going to use that transitive property because we want to know. We want to say that this side is the same as this side, which we can clearly see from the marks, but we need to make it as a statement. So let's statement it. Statemented transitive. Transitive. It's like traveling around. It's transmitting. It's transportationing around to the information around the shuttling it around the diagram. Transitive property. Good, good, great, great. Okay, are we stuck? No, we're not stuck. Because now we can talk about the angles here. Yeah, we know this is a right angle. Oh, we know all these are right angles. Which ones do we care about? Well, if we want to, remember, we're trying to prove that this triangle is congruent to this triangle. We can actually use, if these are right angles, that means these are right angles because they're linear pairs with a 90. The linear pairs have to add up to 180. If that's a 90, that has to be a 90. Linear pairs add up to 180. And that gives us hypotenuse leg. Let's use it. Okay. So we need to say angle G is 90 degrees. Definition of rectangle. Well, yeah, we could just say rectangle, I guess. I don't know if it's definition of rectangle. Something about a rectangle, right? Also angle, oh, which angle G? Oh man. AGE, angle age. Also angle aid. I should put the measure out here, those measure M's. Measure of angle AGE is 90 degrees. Measure of angle ADE is 90 degrees. Okay, let's see. Yeah, we can. Let's do this. Measure of angle AGE plus. So that's AGE plus BGE. Linear pair. This is 90 degrees. That's substitution. Subtract 90 is doing algebra. And now the measure of angle BGE equals 90. Subtraction. Oh, look, we're running out of room. If you skip some of these steps, that's fine. Just know that these steps were implied. In fact, I'm going to take a massive shortcut and say measure of angle EDC, right? This one. If this is 90, that's 90. Linear pair, same logic. I should really restate it, but I'm running out of room. Same reasons. And now we really should say that measure of angle BGE. Oh, nope. Not the measure. Just angle BGE is congruent to angle EDC. We could either say all right angles are congruent, or actually I'm just going to say definition of congruent, because if two angles are congruent, they have the same measure. Well, these angles have the same measure, so that's the definition of congruent. And I'm going to introduce one idea here. This reason definition of congruent relies upon, we haven't been really numbering these, but that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, oh, I'm being summoned to the counseling center. Line 13 relies on line 11 and 12. Because 11 and 12, the two measurements are the same, therefore the angles are the same. That's the definition of congruent. And now we are ready for the big show. Triangle BGE is congruent to triangle EDC. By hypotenuse leg. And where are my ingredients for this? Oh, you know what? I kind of screwed this up. I didn't need this line. All I need is what they were 90s, because it's a hypotenuse leg. So 11, 12, and then way back up here, what are my hypotenuses? My hypotenuses are BE and EC. Line 3. And my legs are BG and ED. Where's BGED? BGED was line 6. So lines 11 and 12 plus lines 3 and 6 together prove this. All right. Evidently I need to go to the office, so we're going to leave this for another day. Bye.